Alright, so describing distributions numerically. So in describing distributions, we need to discuss center, shape, spread, and unusual features. The purpose of this chapter is to show different methods to calculate center, spread, and outliers. Alright, so we're going to quantify these. Alright, how we measure center and spread of a distribution depends on its shape. Okay, so let's talk about a 5-number summary. A 5-number summary is basically 5 numbers from a distribution, starting with the minimum, which is the lowest value, and ending with the max, the highest value. In the middle is what we call the median, MED, and that is the middle number by count or the 50th percentile. Okay, so you got the lowest number, highest number, middle number. Then between the min and the median, okay, or the lowest number and the middle number is what we call Q1, and that's the 25th percentile. And between the middle number and the max is the middle number, which we call Q3, which is the 75th percentile. Okay, so I'll show you how to get a 5-number summary right here. So we have these numbers. So you have the min, you have Q1, the median, Q3, and the max. Well, these are in order, so the min is 60, the max is 100. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So the 5th number is the middle one. So this right here is the middle number. That's 80. Now, these are the lower numbers right here. So in that little 4-number distribution, what would be the middle number? Well, it would be right between 65 and 70, and that would be 67.5. And in these upper numbers, what would be the middle number? Well, they'd be right in between 90 and 95, and that's 92.5. Okay. Now, if you put the numbers in your calculator, which I did here in L1, and you go to Stat Calc, 1-bar stat, for that list, and you'll see these numbers come up, and the top one is the mean, and we're not going to deal with that yet, but just scroll down and there's your 5-number summary. Okay, so there's the min, Q1, median, Q3, and the max. So when you have large data lists in general, they're not going to be given to you in order, so you're not going to have to do this manually. You'd have the calculator do this. Okay, so all a box plot is a graphical display of the 5-number summary. Okay, so in this case we have to go from 60 to 100. So this would be 60, 70, 80, 90, and 100. Okay, so I just mark where my 5-number summary is. There's the min. Q1 is at 67.5. The median is at 80, Q3 is at 92.5, and the max is at 100. So I put those 5 marks there. I put a box going from Q1 to Q3 and capturing the median. So that's the box, part of the box plot. And then I draw what we call a fence from Q1 to the minimum and from Q3 to the maximum. And that is a box plot. So here's the min, Q1, median, Q3, maximum, and that's a graphical display of a 5-number summary. In this case, we can summarize the center by using the median, and we can summarize the spread by using the range. Very simple. Okay, now down on the bottom we got another group. Okay, so let's see if we can do this. Okay, the minimum's easy, that's 25. The max is 100. The middle number, there's 3, 4, 5, 6, 7, 8, 9. Okay, so 80's in the middle. And then in these four numbers, what's the middle number? Well, it would be 70. And in these four numbers, that would be 95. So if I go here, I put these in L2. And all I have to do now is stat calc and then one of our stats for L2. And if I do that, I scroll down, there's our 5-number summary. Okay. Now we got to draw a box plot, right? So now I got to go from 25 to 100. So this is going to go 20, 30. Alright, now that's a box plot. Now before I go on, you can draw a box plot on the calculator. If you go to second stat plot, and you'll notice that I have 2 plots on. I'm going to just turn my plots off. Let's do that again. Second stat plot, and I'm going to go to plot. I'm going to turn my plot on, and then I got to go to, I'm going to use this box plot right here for now. And I'm going to change it for L2 because that's the one we just did. And if I push, now I just push zoom. Nope, hold on. Let me do zoom and Z zoom stat. There you go. And it draws the box plot that we just drew. And if you push trace, it gives you the 5-number summary. So it says right there the min is 25, Q1 is 70, median's 80. Q3 is 95 and the max is 100. So in the second class there appears to be an outlier, right? That 25. If you look at this number down here, this is not really in the distribution. It's all the way from 70 over there. So the outlier rule is that a whisker or the fence can be no longer than 1.5 times the box. Okay, the box is called the interquartile range, which we will refer to as IQR. So here we go. If we copy the, if we look at this data right here, just going to keep this up right for now. Okay, the interquartile range, the IQR, is the length of the box. Well, the box goes from 70 to 95. So to get the IQR, you simply do Q3 minus Q1, and in this case it would be 95 minus 70, which is 25. Alright, so that's how long the box is. Now this fence right here could be no longer than 1.5 times that. Well, I say okay. 25 times 1.5 is 37.5. So this fence can be 37.5. Well, if we do 70 minus 37.5, because we're starting at Q1 and going left, then you would get 32.5. So my fence can go to there, but it's farther than that because my min is 25. So therefore 25 is an outlier. So the way that we do this now is when we do the box plot, we do what's called a modified box plot. Okay. So now what we're going to do is we're going to kind of do the same thing, but we're going to show an outlier, and I'll show you how to do that. So there's 20, 30, 40, 50, 60, 70, 80, 90, and 100. Alright, so there's Q1, median, Q3, maximum, right? There's our box. And we have no other numbers to the left of Q1 except for the 25. But 25 is an outlier according to our outlier rule. So the way that we show that is we show it as a star. Okay? The nice thing is your calculator does this for you. So all we do is we go to stat plot, and if you choose this option right here, the one that's right next to this, see the one that shows the dots in the with the box plot, then we push zoom stat. Watch, we're going to get the exact same graph. So there it is. It's a box plot that shows an outlier. That's called a modified box plot. And those are the kind of box plots we're going to use in this class. So we always want to know where outliers are. Okay. Alright, so now we would still use the median to describe the center, but we would not use the range. Why not? Because we have an outlier. And the outlier artificially shows more variation than really is there. I mean, the entire class really scored here except for this one person. So to say that our range here is 75, well, our, we really, most of our scores are between 70 and 100, so range would not be a good measure of variation here. So we have a distribution as a clear outlier, so we will not use the range to measure spread. Instead, we will use the interquartile range. Or the IQR. So IQR, I already went over this, equals Q3 minus Q1, or the 75th percentile minus the 25th percentile. Okay. We do this because IQR is not susceptible to outliers. Okay. So we can draw both box plots now, use modified box plots on the same scale. Now I'm going to do this on the calculator and then just kind of copy it down. So go to stat plot, and if you turn plot 1 on, make plot 1 for list 1. Okay, and that would be for our, if I go to stat edit, that was for my first list, which was this list right here. Okay, so I turn plot 1 on for list 1, and then I'm going to go to plot 2 and turn it on, make sure it's on modified box plot, and do that for list 2. And if I do stat, zoom stat, it shows both boxes on the same scale. So all I have to do is really use this and copy it down. So let's see, my median's the same. That's nice. My median is the same. Q1 here is to the left. That's 67.5, and that's 70, and then this goes as low as 60. Okay, so, and both of them go as high as 100. So we'll go 20, 30. All right, so let's go through the first list. Let's see, class 1 started at 60, and I'm just tracing this up here. Let's see, I need 60, 67.5, 80, 92.5, and 100. So 60, 67.5, 80, 92.5, and 100. So this is class 1. Class 2, we have an outlier at 25, and then Q1 is 70, median's 80, Q3 is 95 with a maximum of 100. Okay, so now we got to compare. So we're going to talk about 3 things. Center. Okay, so the median score for class 1 was an 80, and the median score for class 2 was also an 80. So the typical score for both classes was the same. there we go, we compared center. Let's talk about shape. Now, one thing you cannot talk about with box plot is modality. You don't know if this is unimodal, you don't know if it's bimodal. All you could talk about is symmetry. And when you look at these both look fairly symmetric. So we're going to say that in both class 1 and class 2, these distributions appear to be symmetric. In class 1, 50% of the scores were between 67.5 and 92.5. And in class 2, 50% of the score, or the middle 50% of the scores were between 70 and 95. Okay, so you compared shape. Spread. Well, we got an outlier. Can't use range, so you got to use IQR. So the IQR for class 1 is 92.5 minus 67.5. In other words, the length of this box. Well, 92.5 minus 67.5 is 25. So we would say the IQR for class 1 is 25. The IQR for class 2 goes from 70 to 95. So the IQR for class 2 is also 25. Okay? So I would say the IQR for class 1 is 25. The IQR for class 2 is also 25. So the variation in both classes is approximately the same. So we talked about center, we talked about shape, and we compared them in context. We don't just say what they are, but we compared them. And then we talked about spread, and in this case we had to talk about IQR. And for shape we can only talk about symmetry because we have a box plot. We can't talk about modality. And for center we had to use the median. Then the last thing I would mention is in class 2 there is an outlier at 25. Okay, so we would talk about unusual features. And that's it. Alright, so the outlier rule. So we've defined that the outlier rule is we need to find the length of the box, which is called the IQR, and that's Q3 minus Q1. And then once we find that, we multiply 1.5 times that, and that's how far we can go from Q1 and Q3, or that's how long our fence can be. So in this problem here, our IQR is Q3, which is 30, minus Q1, which is 20. It's 10. Okay. You multiply that times 1.5, and that's 15. So our fence can go as far left as Q1 minus 15. So our lower end, so we test the lower end, and we would do Q1, which is 20, minus 15, which is 5. So we can go as low as 5. But our minimum is 2. So 2 is an outlier. It's below 5. And then our upper fence, we can do 30 minus, 30 plus 15, which is 45. Well, our maximum is 43, and 43 is not more than 45, so we have no outlier on the upper end. So go ahead and try this problem and then click it back on when you finished. So in this case, we find the IQR first, Q3 minus Q1, and Q3 minus Q1 is 70 minus 58, which is 12, times 1.5, which is 18. So then we do the lower fence, and that's 58 minus 18, which is 40. So our lowest number is 40, minimum is 40, so there is no outlier. Our fence can go as low as 40, so we're in good shape. The upper fence is going to be Q3 plus 18, which is 88. Well, our maximum is 100, and 100 is more than 88, so 100 is an outlier. Now, in both these cases, it should be noted that just because the max is 100 doesn't mean that there's more numbers that are between 88 and 100. So there's at least one outlier. Okay, there's at least one outlier. There may be more. We don't know because of 5-number summary. We don't know how many numbers were in the distribution. Okay, so shape in a box plot. And when we're looking at shape in a box plot, we cannot determine modality. We can't determine if it's unimodal, bimodal, etc., but we can determine symmetry. So if we have a symmetric distribution like we have here, here would be the corresponding box plot. So the median is centered in the box, and the tails are approximately equal. Okay? Now if we have a skewed distribution, this is skewed right, here's what the box plot would look like. So the median is pulled to one side of the box. You can see here the box is bigger on the right, and the whiskers are not equal. In this case, you don't have any fence to the left, but you have a long fence to the right. So the fact that this fence is larger than the one on the left, and the fact that the box is larger on the right than it is on the left, the median doesn't split it right down the middle. Here you would have a skewed left distribution, okay, and this would be the corresponding box plot for that. Okay, so an ogive is nothing more than a graphical display, different kind of graphical display of a 5-number summary. Now these are your percentiles over here, and these are the actual values on the bottom. So we're looking at age at inauguration of probably of a president of the United States. Okay, so in order to do the 5-number summary, I need to know the min. Okay, I need to know Q1, which by the way is the 25th percentile. I need to know the median, which is the 50th percentile. I need to know Q3, which is the 75th percentile. And we need to know the max. Well, the min and the max are pretty simple. The min was right here, that's 40. The max is right up here, that's 70-ish. Looks like it's about 70. Okay. Now I'm going to go, let's do the median, or we can, yeah, let's do the median. We come right over, and we come down. So it's around 55-ish. You might argue it's not exact. Sometimes you got to approximate these as best you can. So I'm going to say it's around 55. Q1 is going to be the 25th percentile, which is right here. I go over, and then I go down. 52, 50, yeah, say around 52. And then the 75th percentile is Q3. And that's going to come down to just about 60. Okay. So the IQR is simply here Q3 minus Q1. So we would do our 60 minus 52. And that would be 8. That's all an ogive is. Alright, so let's talk about measures of center. There are 3 measures of center: mean, median, and mode. So right now we're going to look at calculating the mean and the median and how the distribution changes. Okay, so I'm going to put this data in my calculator, and I'm going to do it a little bit differently. And how I'm doing it right now is this is the values, and this is the frequency that they occur. So this is there's 150, 260s, 370s, 280s, and 190, and that's all I'm putting in, so that way I don't have to type them all in. So we're going to draw a histogram of this. So when I go to stat plot, I got to turn off all my plots. I'm just going to use plot 1, and histogram is this one over here. So I'm going to draw that and use that, and I want to use L1, but my frequency list now is L2. That's the frequency is just the amount of times that they occur if you use it. Most of the time you don't use it, but in this case we're going to. And then I'm just going to push zoom stat. Let's try that again. Okay. Mr. O'Neill forgot to turn the plot on. There you go. Make sure you turn your plot on. Zoom 9. There you go. Alright, so what do we got? We got a perfectly symmetric distribution is what we have. Okay. So we're just going to copy that down. And this goes like this. And then it goes like this. And then it goes like that. So this would be 50, 60, 70, 80, 90, and 100. Alright. So let's calculate the mean and the median now. So we go to stat calc and 1 stats, and we're going to calculate list 1, but our frequency list is list 2, and we're going to calculate this. So our mean is this top number, this X bar, that's the 70, okay? And our median is also 70. So in this case, the mean equals 70 and the median equals 70. Okay. So now I'm going to get somebody who comes in and gets a 25 on the quiz. Alright, so let's just say that this is 40, 30, and then 20. So we would have a bar over here now. We would add that in. So let's go into our list, and let's say that one person gets 25, right? Is that what it was? Yep, one person got a 25. So now we have a perfectly symmetric distribution with an outlier. So we go to stat calc 1 stats, and we're going to recalculate it now. Well, our new mean is 65.5, and our new median didn't change. So outliers affect the mean. Why? Because the mean adds everything up and then divides. So the mean cares what the value is. The median doesn't. If you just put a 25 here, the median doesn't care that that's a 25. It just goes and finds the middle number. Well, the middle number is right in here. It says, okay, well, the middle number is still 70. I don't care that the person didn't do well on the test. Okay? So the mean was influenced the most. This occurred because the mean is calculated by weight of the values, while median is calculated by count. Therefore, the median is not susceptible to outliers. Okay, so that's something to keep in mind. So let's go to class 2 now and draw their histogram. So let's see, we got to get rid of the 25. And let's see, in this case we had 1, 2, 3, 4, 5, 6 50s, 5 60s, 4 70s, 3 80s, 2 90s, and 1 100. Okay, so let's see. So we had 6, 5, 4, 3, 2, and then one person got 100. Okay. And then we still got our stat plot on, so we don't want to go in and turn it on. We're just going to put zoom stat. Oh, skewed right. So is that good? Well, if it's a class, if it's your class taking a quiz, no. Most people failed. Most people got C's and most people got D's and F's. A few people did well, so that's not real good. So here we go. Here's what our Here's what our histogram is going to look like. Goes like that, so that's 50, 60, 70, 80, 90, and 100. So we're skewed right. Remember, skewness always goes to the tail. So, got to calculate the mean and the median. Right. So, let's do that. Here we go. Stat, calc, 1 bar stat. We already got in L1, frequency list is L2. So the mean is 66.67. And the median is 60. Okay. So, when we had a symmetric distribution, ignore the 25, in this case the mean equaled the median. Right? In this case, the skewness pulls the mean. So in this case, the median is less than the mean. Well, why does that occur? It's because the mean takes into account these high values that are over here. These hundreds increase the weight of the mean. Most of the values are in here, but these values over here pull the mean that way. Okay, again, the median doesn't care. The median just says, okay, where's the middle number? Oh, let's see, the middle number is 60. It's right in here. But the mean cares about all these. Even though a few students did really well, the mean cares about those, and so these pull the mean up a little bit. So skewed right, the mean's to the right. Okay? Alright, so let's take a look at this class now. Class 3. So they had 150, 260s, 370s, 480s, 590s, and 6 100s. So let's see this. So it's just the reverse. Okay, so obviously if we graph that, we're now skewed left. That class did very well. Almost everybody got B's and A's. Few people failed. So that's good, right? So we'll do this. 2, 3, something like this. 50, 60, 70, 80, 90, and 100. Okay. Calculate the mean and the median. There we go. So the mean is 83.3. Repeating. And the median is 90. Okay. So in this case, now the mean is less than the median. Mean is to the left of the median. Well, why? Because these values over here pulled the mean down. Again, the median just looks at these values and says, the middle number's in here. But the mean cares about these people who didn't do so well. So it pulls the mean down, even though we had a whole bunch of people who did real well. So when we're skewed left, the mean is to the left of the median. So when we are dealing with skewed distribution, the skewness most affects the mean. The mean is always pulled in the direction of the skewness or the tail. If the distribution is skewed, this happens because the mean is calculated by weight, whereas the median is calculated by count. Conclusion. We want to use the mean whenever the shape of the distribution is roughly symmetric. Otherwise, we want to use the median, as it is not susceptible to outliers, our person who got a 25, or skewness. So if we have distributions with any kind of outliers or skewness, we're going to use the median. If we have a distribution that's roughly symmetric, we prefer to use the mean to summarize the center. Alright, so now variation. We have looked at two measures of variation, right? IQR and range. So IQR is a more powerful tool to measure variation because it is not susceptible to outliers. IQR is always measured paired with the median. No, IQR is the length of the box in a box plot, remember? So if we had a box plot, let me just draw this, hold on. So we had a little box plot right here. Okay, this is the IQR, and in the middle of the box is the median. So IQR is always measured with median. So the third tool to measure variation we're going to look at is called standard deviation. Okay, this is the most powerful tool to measure variation. Okay, standard deviation measures the typical distance each value is from the mean. So obviously standard deviation is going to be paired with the mean, since the mean is part of its calculation. Because some values are above the mean and some values are below the mean, finding the sum of these differences is not useful. Positive cancel out negatives. Therefore, we first square the deviations. Then calculate an average. This is called the variance. This statistic does not have the same units as the data since we squared the deviations. Therefore, the final step is to take the square root of the variance, which gives us the standard deviation. You're probably saying, well, what are you talking about? I don't understand all this yet. Just wait 1 minute. Okay, so here's what we're going to do. We're going to take each value and subtract it from the mean. Now, if we took each value and subtracted it from the mean, some would be above the mean, some would be below the mean. So basically we get all these deviations from the mean that are either positive or negative. Well, when we look at how things vary from the mean, we want to look at their distance from the mean. So basically there was a choice. You could either just make them all positive because you just want to know what their deviation is. That would be taking the absolute value, or you could square them all to make them positive. Well, the statisticians chose to square them. Then they take an average. Well, they divide by n minus 1. Okay. Well, why didn't they just divide by n? Well, there's a story that goes into that, and it's basically because we're looking at the sample standard deviation, and there's variation from sample to sample, and it's not really something you need to worry about. All you need to know is you divide by n minus 1. So that's what we call the variance. Alright, and then to get back to the standard deviation, we take the square root of that. Okay. Okay. And we're going to use that in a second. I'll show you how. Unfortunately, this is susceptible to outliers because it involves the mean. So here's what we have. Class 1 has these scores. So if you add up all these scores, 3, 4, 5, 6, 7, and you divide by 7, you're going to get a mean of 85. So this is the mean. So the first thing we're going to do is we're going to take each value and subtract it from the mean. So 70 minus 85 is negative 15. 75 minus 85 is negative 10. 80 minus 85 is negative 5. 85 minus 85 is 0. 90 minus 85 is 5. 95 minus 85 is 10, and 100 minus 85 is 15. Well, if you were to add all these up, all these deviations up, you would get a sum of 0. Well, that's not what we want to do. Okay, what we want to do then is we want to figure out, in effect, this is 15 away from the mean, and this is 15 away from the mean. This happens to be 15 below the mean, this happens to be 15 above the mean. So now what we got to do is we have to square all of these. That's this part of the formula. So 15 squared is 225, negative 10 squared is 100, negative 5 squared is 25. 0 squared is 0, 5 squared is 25, 10 squared is 100, 15 squared is 225. Now we add all these up. Okay, now here comes the sum part. Okay, sorry, I should have put this in here. It's the sum, so there should be a summation right in there. Okay, forgot to put that in. So that's 225 and 225 is 450, 550, 650, 700. Okay, so that's the sum. Now I got to divide 700 by 7 minus 1 is 6. So if I divide 700 by 6, you get 116.67. And then the last thing we got to do is take the, that's, by the way, is now the variance, and then the standard deviation, okay, which I'm going to label as S, which is the sample standard deviation, is going to be 116.67 divided by, sorry, square root of 116.67, and that's 10.8. Okay. Now I could get into this whole thing about parameters and statistics right now. There is a standard deviation out there for a population, and that's called sigma. Alright, and the difference between sigma and S is sigma is for the entire population. So if I wanted to know the standard deviation of every student that took an SAT maths test, that would be sigma. But if I wanted to know the standard deviation of the students who took the SAT math at your school, that would be S, because that's the sample of all the students that have taken it. So right now we're going to be dealing with S, because that's what we're going to be dealing with in this course. We're going to be dealing with samples, and therefore we're going to be dealing with sample standard deviations, and we're going to use these to approximate what sigma is. But that's all you need to know for that right now. Okay. Now, the nice thing is, let me just show you this. If you were to put this data in your calculator, that's this list 1 over here, and you were to go stat calc 1 var stats, and now we don't have a frequency list, so I'm just going to change that to 1. Okay, and go to, okay, let me just clear that out then. And if I was just to go to calculate, you see this S sub x that's right here, this that's a sample standard deviation. That's the 10.8. So the nice thing is our calculator does this for us. So now we got another class. So if we look at the first class, we went from 70 to 100. So if we look at the second class, they went from 77 to 93, and it looks like had less variation than the first class. So let's see what happens. So we had 77, 79, 81, 83, 85, 87, 89, 91, 93. So 1, 2, 3. Okay, so what's our mean here? Here's the mean again, it's 85. So I take each value and subtract it from 85. I get -8, -6, -4, -2, 0, 2, 4, 6, and 8. And if I add up all the deviations again, I would get 0. So now I square them. So here we go, we square the deviations. We get 64, 36, 16, 4, 0, 4, 16, 36, 64. Okay, and if I add all these up, that's the summation now. Let's see, this is 100, 200, 220, so I would get 240. Okay? Now I take the 240 and divide by n minus 1. Well, there's 9 values, so I divide by 8, and I get 30. Okay? That's the variance. And then I would do the square root of 30 would be my standard deviation, and let's see, and I get about 5.5-ish. Okay. So this is how we quantified the variation. Well, we said that this had a standard deviation of 10.8. This class had a standard deviation of 5.5. Well, what does that mean? It means that class 2 had less variation than class 1. They were more consistent in their scoring than class 1 was. Does it mean that they did better? No. Does it mean they did better? I mean, this class had 3 kids that got an A. This class only had 2 kids that got an A. So you can argue that maybe class 1 did better. But the point is that class 2 was more consistent. Okay? So let's take a look at now class 3. Okay? And by the way, I could verify that. Let's go to Stat Calc, 1-bar stats. I put this in list 2. And there's our standard deviation of 5.5. So class 3 had all 85s. All right. Well, they were real consistent, weren't they? Okay. So obviously the mean here was an 85. So deviations were all 0. And if I square those, 0 squared is 0. And then if I take those and divide those by n minus 1, I would get 0. That's the variance. So the standard deviation is the square root of 0, which is 0. Well, what does that mean? It means there was no deviation at all from the mean. Everybody got the exact same score. Okay, so it doesn't necessarily mean they're better. What if class all got 50s? That wouldn't mean they were better. It just means that they scored consistently. Okay, so that's basically how we do standard deviation. Okay, so it's just a way of quantifying variation for us. Alright, so key points to remember. We determined that the mean is used when we have a symmetric distribution, because mean is susceptible to outliers and or skewness. So we don't like using the mean when we have either one of those two issues present. Okay, since standard deviation is calculated using the mean, we must have a roughly symmetric distribution to use this powerful tool. Okay. So let's sum this up. Range can be used as a measure of variation as long as there are no outliers. Okay. IQR and median can be used for any distribution because median is not susceptible to outliers. These are also used with skewed distributions. So we use median with IQR with skewed distribution. Remember that the IQR always goes as a measure of variation with the median. So if you use the median, you talk about IQR. If you talk about IQR, you use the median. The most powerful tool to measure variation is standard deviation. This involves finding the mean. These are best used when we have a roughly symmetric distribution. Remember that standard deviation always goes as a measure of variation with the mean. Okay, so you have 3 measures of variation: the range, the IQR, and the standard deviation. The IQR always goes as a measure of variation with the median, so median is a measure of center. And then whenever we use standard deviation, we'll use mean as our measure of center. But the condition is to use mean and standard deviation, we must have a roughly symmetric distribution.